to see what they really look like. That first one, f of x plus h. So let me give you some specific examples of what we're looking at there. That was the first example that we did yesterday. The absolute value of x plus 2. If it were a square root function, that could be the square root of x plus 3. Another function that we have dealt with, x plus 4 squared. Or exponential, may have some experience with that, may not. You'll definitely have some experience with that after this class. 2 to the x plus 5. The plus 5 is with the x in the exponent. So all of these, it doesn't matter which function it is, that is going to move left h units. However much h is, it's going to move left. So when that's a plus, we're moving left. So the opposite of what we would expect, right? Positive, we think we associate that with the right, but this moves to the left. Similarly, I'm not going to do as many examples because it's the same thing. We're just changing the sign. The absolute value of x minus 2. How about x minus 4 squared? Okay, so same structure. We're just changing the sign. So that means we change the direction. Instead of left, we're going right. That many units. So the minus is right. Okay, so the horizontal is the opposite of what we're expecting it to be. Now, yes, I'm presenting this to you this way. I'm not expecting you to memorize this list. If you think this way and it makes sense and you can memorize these patterns, go for it. But push comes to shove, you can always graph them and observe them, okay? So let's look at how things change when it's f of x, close the parentheses, plus k. So that changes it from being inside the absolute value to outside the absolute value. The absolute value of x plus 2, or the square root of x, where the x is the only thing under the square root, the plus 3 is outside of the square root. With our quadratic function, you square the x and then you add 4. And with the exponential, 2 to the x and then you add 5. It's not in the exponent anymore, it's after the exponent. But this is going to move up k units. This is what we expect. If we add something and we're thinking up and down, plus would correspond to up. So that's what we're expecting it to be, opposite of your horizontal changes. So similarly, again, I'm not going to exhaust this list here. Square root of x minus 3, x squared minus 4. Obviously, I could change all the signs of the other one, but that minus is going to move us down k units. And the only reason why they use a k instead of an h is just to designate between the horizontal and the vertical. There's nothing special about it. It's just representing a number. Now, let me show you something. I mentioned that you could observe these changes in the graph. Let me show you something really cool that Desmos will do. Let's just use the absolute value of x since we were comparing to it yesterday. So that's the parent function. That's what we're comparing it to. Instead of putting a specific value, so I'm trying to observe what happens with that first function. Instead of putting a specific value right there, I'm going to put plus h, like is on our table there. And it asks if I want to add the slider. So when I click that, it automatically starts at a value of 1. I can drag this number right here, and I can watch that function move, and clearly it's moving to the left. And these are positive h values. If I slide it back, and I come over here, and this is like minus h because they're negative values here, where's it going? It's going to the right. So again, you can memorize it, or you can observe it on the graph, and it's really cool. I mean, you can do this even on the EOC. Like, this is the NC test version the sliders are available to you on the EOC. All right, so let's finish out our list here. Let's talk about dilations, stretching, and shrinking. So if we multiply our function by a constant, when that constant is greater than 1, so for example, 2 times the absolute value of x, or -3 times the square root of x. Now, yes, I purposefully chose -3 because it says the absolute value of that number is greater than 1. Okay, the negative, we're going to get to that here in a minute, but the 3 is what we're focusing on right here. Or 4x squared, that's another example. Or something like this, 5 times 2 to the x. Now, if you remember anything about exponentials, you cannot multiply the 5 times the 2. That's not a typo. That's the way that it may show up in a function. But this is a vertical stretch. And yes, you have to be specific that it is vertical, because there are also things that we can do to our function. We're not going to talk about them, but there are things that you can do to horizontally stretch. So you do need to be specific that this is a vertical stretch. And similarly, we can, when our value is less than 1, so 1/4 absolute value of x, -1/8 x squared, that would be a vertical shrink, or you may also see the term compression. It's either a vertical shrink or a compression. Now, be careful. A lot of people tend to want to say that when A is a fraction, it's always a vertical shrink or a vertical compression. What about if our A was 7/2? Okay, would 7/2 cause an actual vertical shrink or compression? I don't know. Let's see what happens right here. Whoops, still need my X. Okay, if there was a 7/2 in front of this, the red is the transformation. Did that get taller or did it get shorter? It got taller. It did stretch vertically. So 7/2 caused a vertical stretch. Why did 7/2 cause a vertical stretch? Because 7/2, yes, it's a fraction, but that is a number that is greater than 1. So be careful that you don't generalize and say that if this number in front is a fraction, it's automatically a compression. It's not. You got to check whether that fraction is greater than 1 or not. Okay, almost there. Reflections. Okay, we have 2 types of reflections, negative f of x and f of negative x. So negative f of x, we looked at that one yesterday. That's if the negative is in front of the function. So the negative absolute value of x, the negative square root of x, negative x squared, or negative 2x. Those always reflect over the x-axis. Again, you can very easily see that if you graph the original and graph whatever transformation you're looking at. It's very easily observable. F of negative x, on the other hand, that's where the negative is with the x. It's not in front of the function. It's with the variable, and that's going to reflect it the opposite way. That's going to reflect over the y-axis. All right, so that's all fine and dandy. The reality is the majority of the time we're not going to just be observing one single transformation at a time. A lot of times they will be combined. So let's look at some examples on the back. We're going to describe these transformations and any effects that it has on the domain or the range of the parent function. So in some cases it will change, in some cases it will not. So we do need to identify the parent function. I haven't talked a whole lot about that. I did mention it with the absolute value at the beginning of the notes yesterday. But it's just focusing in on what is the very original function. Nothing added to it, nothing subtracted to it, nothing multiplied, no negatives, just a plain old function. So for this first one, we're comparing it to the absolute value of x. And we've got x minus 1, and then outside minus 4. I like to use the vertex as a reference point. So our original vertex is at 0, 0. Our transformation has a vertex at 1, negative 4. So that makes it pretty clear what has happened. We have moved right 1 and we have moved down 4. So right 1, down 4 is our transformation. The domain and range. The domain did not change. You're never going to change the domain of the absolute value function. It's all real numbers. It will always be all real numbers. But the range did change. Look, we had a minimum before at 0, 0. Now we have a minimum at negative 4. So let's just write down that our domain is negative infinity to infinity. Nothing changed there. Our range, it did change from negative 4 to positive infinity. We now have a minimum value at negative 4. And just to continue re-emphasizing interval versus inequality, that is y is greater than or equal to negative 4. You need to be familiar with both notations. Okay, second example, we've got negative x minus 4 squared plus 5. Parent function here is the quadratic x squared, plain old x squared. So it's up to you what you want to do in Desmos. I would suggest just hiding these other functions, because here in just a minute I'm going to ask you to do some absolute value. So don't delete it, just hide it so you don't have to type it in again. We want to compare it to just x squared. That's the parent function. If you want to change the color so you can, your parent functions can be in black and your transformations can be in a different color. It doesn't matter to me how fancy you want to get about that. I think it's helpful to see it in different colors. Type in your entire transformation there. Negative x minus 4 squared plus 5. So we've got a couple of things going on here. First of all, I compare the vertices. Okay, the vertex of the original one was 0, 0. The vertex of our transformation is 4, 5. So we have moved right 4 and up 5. So right 4 and up 5. Something else has also happened. Our parabola is not facing the same direction. So there has been a reflection. It has flipped over the x-axis. And we've reflected over the x-axis. That's that negative in front right there. You should be able to see in the equation, you should see that there are three things. There's a negative in front, there's a minus 4, and there's a plus 5, so you should have 3 details to your transformation. The domain here is still all real numbers. Nothing is going to change that about your x squared function. The range has changed. We now have a maximum value of 5. So if we go bottom to top, we've got negative infinity up to positive 5 for our range. So negative infinity to positive 5 that are less than or equal to 5 in the other notation. All right, one more. Parent function of number 3 is the square root of x. Again, I would not delete all that. I would just hide it and then add my square root of x. And let's see here, we've got 5 over 2. The square root of x minus 1. Now this one is a little bit, you got to know a little bit more about the function here because, well, actually it does. I didn't think that it gave you the endpoint. Sometimes it does, sometimes it doesn't. I think here it does because those are both y-intercepts. It gives you that point. A lot of times with the square root function, it does not give you that starting point right there. So you kind of have to click and drag and see how close you're getting to the end and get the point that way. But anyways, we've got it here so we can clearly see we went from 0, 0 to 0, negative 1. So we went down 1. And then if we zoom out a little bit, we can tell that our transformation is definitely taller than our original function. So not only did we go down 1, we have a vertical stretch.